Welcome to Machine Learning Explained. In this series, we will explore the fascinating world of machine learning, how it works, and why it matters. Machine learning is a transformative technology that enables computers to learn from data and make predictions without being explicitly programmed for every task. From recommendation systems on Netflix to autonomous vehicles, machine learning powers many of the technologies we use every day. Over the next slides, we will break down the main types of machine learning, explore real-world applications, discuss emerging trends, and show you how to get started in this exciting field. Supervised learning is the most common type of machine learning. It learns from labeled data, meaning the computer is given examples where both the input and the correct output are provided. Think of it like learning with a teacher who tells you the right answers. There are two main approaches within supervised learning. First is classification, which predicts categories or classes. For example, filtering emails as spam or not spam. Second is regression, which predicts continuous numerical values. For instance, predicting house prices based on features like location and size. Supervised learning is powerful because the labeled data guides the model to learn accurate patterns. Unsupervised learning works with unlabeled data, where the computer must discover hidden patterns and structures on its own. Imagine sorting a pile of photos without being told what to look for. There are two main types. Clustering groups similar data points together. For example, segmenting customers into different groups based on their purchasing behavior. Dimensionality reduction simplifies data by reducing the number of features while keeping important information. This helps with data visualization and compression. Unsupervised learning is valuable when you don't have labeled data or when you want to explore and understand the underlying structure of your data. Reinforcement learning is fundamentally different from supervised and unsupervised learning. It works through trial and error, where an agent learns by interacting with an environment. The agent receives rewards for good actions and penalties for bad ones, continuously adjusting its behavior to maximize cumulative rewards. This process happens in three stages. First, exploration, where the agent tries different actions to discover outcomes. Second, feedback, where the agent receives rewards or penalties based on its actions. Third, adjustment, where the agent updates its behavior to get more rewards. Reinforcement learning powers game artificial intelligence and robotic control systems. For example, AlphaGo used reinforcement learning to master the game of Go by playing millions of games against itself. Let's compare the three main types of machine learning in one quick view. Supervised learning uses labeled data and aims to predict known outcomes, perfect for email classification. Unsupervised learning uses unlabeled data to find hidden patterns, ideal for customer grouping. Reinforcement learning uses interactive feedback to maximize rewards, excellent for game artificial intelligence and robotics. Each type serves different purposes and is chosen based on your data availability, problem type, and objectives. Understanding these distinctions helps you select the right approach for your specific machine learning challenges. Machine learning is transforming industries across the globe. In healthcare, it detects diseases early, assists doctors with diagnoses, accelerates drug discovery, and predicts patient risk. In entertainment, platforms like Netflix, Spotify, and YouTube use machine learning for personalized recommendations. In transportation, machine learning predicts traffic patterns, powers autonomous vehicles, and optimizes ride-sharing services. In e-commerce, it recommends products, adjusts prices dynamically, and detects fraudulent transactions. These applications demonstrate how machine learning creates value by making services smarter, faster, and more personalized. As technology advances, we will see machine learning integrated into even more aspects of daily life. The machine learning landscape is rapidly evolving. Autonomous decision-making systems are taking over critical functions in finance and healthcare without human intervention. Generative artificial intelligence is creating text, images, and code automatically. Edge computing processes data directly on devices for faster, real-time responses instead of sending data to the cloud. Ethical artificial intelligence focuses on building transparent and unbiased systems with clear accountability. Machine learning operations, or MLOps, streamlines how models are deployed and monitored in production environments. Finally, quantum machine learning uses quantum computing to accelerate machine learning for extremely complex problems. These trends will shape how machine learning evolves in the coming years. Machine learning offers excellent career prospects with competitive salaries. Machine learning engineers build, test, and deploy models that power real-world applications, earning around $168,730 annually. Data scientists analyze complex datasets and extract actionable insights using machine learning, earning approximately $165,029 per year. Artificial intelligence research scientists develop novel algorithms and advance the field through groundbreaking research, earning over $180,000 annually. Natural language processing specialists create algorithms that help computers understand and generate human language, earning around $180,727 yearly. These high-paying positions reflect the growing demand for machine learning expertise and the shortage of qualified professionals in the field. Starting a machine learning journey requires a structured approach. Stage 1 is foundation, taking 3 to 4 months to build core knowledge in statistics, Python programming, and basic machine learning concepts. Stage 2 is core skills, requiring 4 to 6 months to master supervised and unsupervised learning, model evaluation techniques, and feature engineering. Stage 3 is advanced topics, taking 6 or more months to explore deep learning, reinforcement learning, and natural language processing. Stage 4 is practical projects, an ongoing process of building end-to-end applications and solving real-world problems. Stage 5 is certification, earning credentials from providers like Amazon Web Services, Google Cloud, or Microsoft Azure to validate your expertise. Stage 6 is career launch, applying your skills to land positions as machine learning engineers, data scientists, or artificial intelligence specialists. Here are the essential points to remember. First, there are 3 core types of machine learning: supervised learning with labeled data, unsupervised learning finding patterns in unlabeled data, and reinforcement learning through rewards and penalties. Second, machine learning has universal impact, transforming healthcare, finance, entertainment, transportation, and e-commerce industries worldwide. Third, there is growing demand for machine learning professionals. With salaries ranging from $160,000 to $180,000 or more, and a significant skills shortage, this is an excellent time to enter the field. Fourth, machine learning is continuously evolving with emerging trends like generative artificial intelligence, edge computing, and ethical artificial intelligence reshaping how models are developed and deployed. Begin your journey today and become part of this technological revolution.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.